everyone. Nice to meet you all. Thank you for joining me for this session today. And today I'm going to talk with you about how to troubleshoot and monitor your production application using OpenTelemetry. So what is the agenda for this session? First of all, I give a short introduction about what is observability. Then I continue to talk about what is OpenTelemetry and how we can leverage this amazing open source project to gain a better observability and monitoring for your applications. We will continue when I show a cool use case of how you can diagnose a memory leak in your system and how you can fix this issue without debugging. And if we will have time, I will show a live demo of using OpenTelemetry and Teletrace and how we can find a root cause of an error that occurred in our system. But before it, a couple of words about myself. My name is Haim Raitsev. I work at Cisco, Outchip department. Previously, it called ETNI, Emerging Technology and Incubation Group. I'm an engineering group leader, and I'm leading the development of Teletrace. Teletrace is an open source distributed tracing system that helps developers to monitor and troubleshoot production applications. In addition to it, I'm a UI guild leader. So let's start. First of all, who is familiar with observability? Who thinks he has a good observability in his work? Okay, nice, good, I like it. Okay, so what is observability? The definition is that observability is a measure of how well internal states of a system can be inferred from the knowledge of its external outputs. Okay. Pretty hard to understand what is it. It's not simple, but in simple terms, observability wants to answer on two simple questions. The first question is what is happening inside the system, inside our system, and the second question is why is it behaving the way it is. So if we will look on this simple example, we can see here that it is a web application. We have a REST layer that handles our different requests. Then we have the business logic with some different models there. And then we have the data access layer that connects to our MySQL. And after we finish the development, we want to deploy it somewhere. So because it's a monolith architecture, we deploy it in a single host, and everything is working correctly. To understand that everything is working correct, we usually install an agent that will collect some logs about our application and send it to some metric storage. Then we will be able to create a dashboard and to hopefully to understand that everything is working and everything is correct and everything is working correctly. But what's happening if we have an error in our system? We usually have to go to and look inside our host to search for logs. Then we usually will install another agent that will collect the different logs in our system, send it to some logs aggregator, and then we hopefully will use another logs visualizer. For example, Elasticsearch is a good open source example. And then we hopefully will find the relevant log and hopefully fix our issue. But it's a little bit hard to do. You pretty have to. It's a process to do it, but it's doable. But what is going on when we are moving to a microservices architecture? In these days, more and more companies are moving from monolith architecture to microservices architecture, and they have pretty much reasons to do it. First of all, it's more scalable. You can scale easily your application or only parts of your application if needed. It's reduced the radius of bugs because each team has a small focus. They focused on a specific microservice with a specific responsibility. And in some cases, it can reduce the development time. But it also presents some challenges to the development teams. Let's look on this example. This is an example of a simple microservices architecture with many different microservices here that's written in Node.js. In addition to it, you have like two different databases, Redis and MongoDB. And then you have a third party. For example, in this example, it's Auth0 that handles the authorization of your system. So you have pretty much different components. And if you think about it, if we are going back to the definition of observability, we want to know in which state our system it is. So it's pretty hard because you have many different flows here, many different components, and if I ask you in every single moment in what state every single of these components, it's really hard to answer on this question. So in these days, the development teams are challenging with, and are facing with three major challenges. The first challenge is called modeling. We want to understand how we want to model our system, how our system is look like. As I said before, we have many kinds of microservices in our system. We want to know which microservice in which state, and which of them is participating in which flow. If you're going back to these examples that I showed before, so you have like many different flows, many different microservices here. It's hard to understand which component or microservice participating in which flow. So to model and understand which service is connecting to which flow is the first challenge that the dev team is facing with. The second one is troubleshooting. Let's say we have an alert that we have too many internal server errors in our system. So searching for the root cause is really hard. Think about it. We need to find the relevant log. Then we need to correlate and jump between different microservices and to understand which log is correlate to the problematic request. You need to search in each service for the problematic flow. It's really hard to do it. It's not easy purpose. Then we have the optimizing. Let's, for example, say that a customer complains that a certain flow is not fast as it should be. Again, we need to find and understand which services are participating in this flow, and we need to understand which service is caused the latency. Maybe it's the database because it don't have insufficient resources, or maybe it's a new logic that we added recently by a new developer. But don't worry, in the observability world, we have the three pillars of the observability that help us to struggle with these challenges, to overcome these challenges. The first one is metrics. In simple terms, metrics are numbers over a timeline that help us to understand what happened in our system. They show a trend. Then we have the logs. The logs are data records that can be structured and not structured, and they are the most essential kind of output that usually almost every system produces. And then we have the traces that show where something happening. If we are talking on a microservices and then on distributed systems, we want to talk about distributed traces. We need to talk about distributed traces that tell us where something happened in our system. Let's look on this example. This is an example of a trace. When a single tile here in this trace called a span. A span is a single unit of work. Think about it, it's like an event or request that happened in your system. A really simple, monolithic, atomic work that your system produced. If we collect all spans together, we will have a trace, like in this example. This is an example of a time view of a trace. So here it's easily understand which span take the most part of the time of a specific request. So if we look on this example, we can easily infer that, for example, the B or A span, they took the most part of the time of the specific request. This is another example of a trace, but here it's a graph view. Here only if by looking on this graph, we can infer that, first of all, we have an error in our system. In this case, it's with the red lines. Moreover, we can understand that when the user click on checkout and make the checkout request, we can infer that the error is bubbled from the discount service. Moreover, we can remove that the issue is not in the cart service or in the inventory service, and the problem is here. So we can easily understand that we have an error and we have an issue that happened in discount service. If we will think about it, each node in this distributed trace is a resource of our system. It can be a database, it can be a microservice, and each node and each arrow here, it can be one or more spans. So if we collect them together, we can build this kind of graph. And now think about how to implement all this. First of all, you need to create an instrumentation. You need to instrument all this data. You need to collect all these spans together. You need to propagate the context. Moreover, you need to export this data somewhere. You need to store it in some storage. And you need a visualizer tool that shows you how a trace looks like. So, in context and of OpenTelemetry is a cool tool that provided for us to answer these questions and do this work for us. For example, OpenTelemetry is a really cool open source project that's backed by CNCF, Cloud Native Computing Foundation. That means it's not backed by a single company. You have very wide various of companies, maintainers, and contributors that support this project on a daily basis. But let's continue to understand what exactly does it provide. So OpenTelemetry is a collection of tools, APIs, and SDKs that we use them to instrument, generate, collect, and export the telemetry data, which are metrics, logs, and traces. And it helps us to analyze the performance and the behavior of our system. Let's look on this architecture. This is a simple architecture of an application that's using OpenTelemetry. And let's go over of the different components that OpenTelemetry provides. First of all, we have the APIs and the SDKs. They can be part of our application, or they can run beside our application. The purpose of them is to generate the different telemetry data, metrics, logs, and traces. Then we have processors and exporters. They also can be part of our application, or they can run beside our application. The processors process the data. They can, for example, enrich our data with some context that the user wants to add for specific telemetry data, for example, user ID or request ID. And we have the exporters that export the data to a collector or directly to a different telemetry backend that I will talk about it in a moment. If we're talking about the collector run beside our application. It's another service that's running. It receives the data, the telemetry data for all different applications. It can process the data as well, and it exports it to a telemetry backend. Then we have the different telemetry backends. Telemetry backend is not part of OpenTelemetry. It's outside of the scope of OpenTelemetry project, but I will talk about it later, which solutions we have in the market. The first thing that OpenTelemetry provides is the specifications. The specifications are the definitions of how the telemetry data look like. For example, what is span and what is trace and how does metric look like. It means it's the standard of the telemetry data in the open source world. And if we are talking about what another stuff that specification produce for us, it defines which SDKs we will have, which programming language we support, and what is the expectations from SDKs in every single programming language, how the APIs will look like, and it actually says what is implemented for every programming language. Then we have the languages SDK. So OpenTelemetry support a wide different programming languages in the market. For example, Golang, JavaScript, TypeScript, Python, Java, .NET, many kind of programming language that you can think about it or not. They have like a huge kind of support for many, many different programming languages. And the actual implementation of the specifications that we see in the previous slide. Usually we have two different repositories for every programming languages. The first one is called the core repository. There you can find the actual implementation of the specification. There you can find the core implementation. And another repository that we have is called the programming language name underscore contribute. There you can find the extensions that people added, that the contributors, the different contributors added. And there you can usually find the processors and the exporters that export the data to range of backends, or it can export the data directly to the hotel collector, which I talk about it in a moment. But before it, I want to go with you and talk about a really cool feature that we have in OpenTelemetry. It's called automatic instrumentation. Think of a trace. In this example, we have like many different kinds of microservices. Here, everything is written in JavaScript, but think global. Think about a big company. You maybe have some teams that develop, part of them develop their code in JavaScript, and others can develop this code in .NET or maybe in Python. So we want to have a tool that will do all this part of creating spans, exporting these spans for us with minimal change of code. So for this, we have the automatic instrumentation. Think about it. If we think about a single span, what we will have there? First of all, we need to know when the span started and when it ended. Moreover, we need to know and to collect some metadata on this span. For example, request ID, user ID, transaction ID. And we want to collect some data for the specific framework. For example, if it's a HTTP request, we want to know what is the request method, what is the response code, and maybe some headers that the request did. So all this thing of wrapping and creating these spans, all of this is coming with automatic instrumentation by OpenTelemetry. So you can gain all this powerful stuff without changing a code or with minimal change of code. For example, if we think about Java, you have a Java agent that runs beside you and collects this data. And you almost don't need to change any code, and you can gain this powerful tool, hopefully with any change of code. Now we have the collector. The collector is a tool that runs on a single host. It can be a service that can run beside your application, or it can be a pod that runs in your Kubernetes cluster. It receives the data for all different kind of applications that using OpenTelemetry. It processes the data. In the processor, you can remove data or enrich the data, and it exports it to the telemetry backends. But if you go back to these architectures that I showed you before, you can ask me why to use it or when to use it if we can export the data directly for our application to telemetry backend. So why to use this collector? I find several reasons to do it. First of all, we want to make a decoupling between our application and the telemetry backends. Think about it. If the telemetry backend is a SaaS solution that's running in some other's cloud and they have an issue, so we don't want that our application will start to throw errors that it can sending the data to the telemetry backend. We want a single place to do it for us. Moreover, think about it if we want to add some processor, for example, remove sensitive data. If we want to remove passwords from sending them to some third party, so instead of doing it in every application, we want a single place to do it for us. Moreover, if we want to optimize the application performance, if we want to remove some logic, some unnecessary data, we want to do it in one single place. So all the overhead from the application of configuring each application to sending the data directly to the telemetry backend, we can configure all our application sending and export data to a collector. And from a collector, we can export the data to different telemetry backends. For example, we can configure that the OpenTelemetry collector will send the data for a logs telemetry solution and telemetry backend, and for a different solution for metrics. So everything we can do with the collector. Now let's talk a little bit about the different solutions that we have in market that called OpenTelemetry backends. we have really wide range of solution for many different use cases. And this part of them, first of all, we have Deepkin and Jaeger. These two solutions are open source, so it's not a SaaS solution. It's self-hosted. You have to manage it by yourself in your own cluster. And they solutions for traces visualizer. In addition, you have Prometheus, that it's a really popular solution for metrics storage, and it gives a solution for metrics visualizer, but it also provides a solution that can storage OpenTelemetry metrics. And the last solution is, in my opinion, the most popular. It's called Grafana. It can show and visualize different wide of solutions. For example, Jaeger can be a data source of Grafana. Prometheus can be a data source in Grafana. These are really powerful tools that help you to create some cool dashboards and define an alerts. At Cisco, we have something that's called Teletrace, open source tracing platform, that helps you to troubleshoot and monitoring your distributed application using traces. It supports OpenTelemetry native. You can find it here. I will show later an example of how to use it, but it's really full open source solution that you can use it to view some timeline views and graph views, and I will show later how to use it. If we are looking for some commercial solutions, and we want some SaaS solution and not to manage the open source solution by ourselves. If we want, for example, full support, or we want some solutions that we pay for someone that will host this project for us, you can visit OpenTelemetry.io at vendors. And here you can find a very wide solutions of different telemetry backends. At Cisco, we have something that's called AppDynamics Cloud, which is a monitoring and troubleshooting cloud-native solution that support OpenTelemetry natively. And basically, this solution can work with traces, logs, and metrics. Before I continue, I want to talk a little bit about the community that we have behind the OpenTelemetry. First of all, we have the documentation. In the documentation, you can find a wide range of examples of how to run, how to instrument, how to use automatic instrumentation, how to work with OpenTelemetry, which kind of telemetry backends we have there, how to configure everything. Then we have the GitHub repositories. You can search for the specific repository for your specific programming language, and there you can search in the issues, and in the open issues, you may create a discussion and talk about how to and search from previous issues and understand how everything is worked correctly. Moreover, CNCF provide a Slack workspace for OpenTelemetry. There you can find a Slack channel for specific programming language or for every sub-project in OpenTelemetry. Then there you can connect to this workspace and ask directly questions the maintainers and the contributors. They will help you to start to work with the project. If you want to contribute with the project and take some issues, you're more than welcome. You can do it as well when you are using and connecting the Slack channel and talk with the maintainers. And another interesting thing that we have in this community, it's called CIG, SIG meetings. SIG is Special Interest Group. For every sub-project in OpenTelemetry, we have a group that's responsible for this sub-project. They have, usually they have a meeting once a week. And if you want, you can add an item for their agenda, and they will talk about it. For example, if you want how to work with something, or you have an issue that struggled when you tried to instrument some framework in Python, or you can ask them why the automatic instrumentation don't work for some framework in JavaScript. You can do it by adding an item to their agenda, and the maintainers will talk about it in the next SIG meeting. Really a cool solution for actively answer a question from users and from clients. Now let's talk a little bit about the maturity of the project and in which state is it. So if we're talking about OpenTelemetry, we usually have 3 different stages. The first stage is called sandbox. Sandbox, it means it's accepted by CNCF, Cloud Native Computing Foundation that I mentioned before, and it has the Apache 2 license. If we're talking about the incubating stage, it means that specific project have a community of contributors and a user base, and it has different versioning. So you can use latest version of this project or previous version of the same project. So it's not the first version of this specific project. If we're talking about the graduated stage, so it means that the project reach a maturity. You have a wide base of users. You have a wide range of contributors that support this project on a daily basis. Moreover, if a project is gain the incubating or the graduated stages, it means it's ready for production. So you can use it in production without any hesitations, because you have a really big amount of users that using it, and you can use it without any fear. OpenTelemetry is a kind of here, it's after the incubating stage, so you can use it in your production, and you can enjoy from all it can provide for you. Another great tool that's provided by OpenTelemetry is called OpenTelemetry Community Demo. It's simply an application, a web application, a web storm that sells some telescope equipment. A little bit strange, but okay. And this is the overview of their application. So you can see here that in this demo, you can find many different microservices. Each microservice is written in different language, programming language. So if you want to start and work with OpenTelemetry and you want to learn how to instrument, how the spans and the metrics and logs look like, how to work with this telemetry data, how to export this telemetry data to some backend, you can use it with this amazing project. It will show and help you how to start with OpenTelemetry. Now I want to go with you and to talk a little bit about how to find and diagnose a memory leak in your system. I think that memory leak, it's a pretty hard issue that happened in every system, and it's really hard to troubleshoot it and find the root cause that's causing this problem. So let's look on this example. This is a Grafana dashboard. I hope you see it okay. But I want to point you on two panels here. The first one is here in the left corner, in the bottom. You can see that the latency of specific service, that's called recommendation service, is dramatically increased. Moreover, I can look on the error rate issue, and I see that we have no errors. So it can point us that maybe we have some memory issue in our system, because we don't have any errors in our system, but the latency is increasing. So what we can do? First of all, we diagnose that it can be a memory leak. Then we open a teletrace. I hope you see it well, but in teletrace, you can, it's a visualizer of spans. Here, this view called span search. In the left panel, you can see recently used filters, and here you can filter the recommendation service. So here you will view and see only the only the spans that are related to the recommendation service. Moreover, we sort for the duration, and we can see that the duration is dramatically increasing. So what we can do? We can click on a simple span. For example, let's click on this one or that one. And after it, it will open a new view that's called a trace view. Before we was in a context of spans. Now we can, now we can see the full trace that span is part of. Here we can see the timeline view that I talked about it before. We can easily understand. You can't look here, but you can see here. But believe me, that the problem is caused from the get products list function, because you can see that this almost takes the most part of the request. So if we will click on it, it will open the trace graph view. Here is our full trace. And on the right side, we can see the tags panel. And here I can point you on two strange things. First of all, you can see here that you have a lot of metadata and specifically attributes for this specific request. And here we can see that we have cache underscore hit, and it's false. Okay, strange. Why the cache property is false, but maybe it's okay. And we can see that the app.products.count property, we have a really huge amount of products that get back from this request. So, okay, what we can do, we can go back to the span search view, and here we can search for a recommendation service with the app cache hit true, and compare it with recommendation service with when the app cache hit is false. And here we can see that the duration here is 10 times bigger. So without any debugging, only because we have a good observability in our system, we can infer that we have maybe a memory leak, but moreover, that the problem is in this specific property, in the specific functions that called get product list, and everything is in the recommendation service without any debugging. So it's really cool, and it's a really powerful tool. So we have time. So the next thing that I want to show is a short demo of how to use everything. Okay. So this is the OpenTelemetry. Everything is running on my local machine. You can run it and deploy it to Kubernetes, but I deploy it with Docker Compose, and you have like a really many microservices that running in parallel. And this is the application. This is the application of the OpenTelemetry provide, and it's telescope e-commerce for telescope, sells some telescope equipment. And if we will look, we can click on this item, and we can see that something is got wrong. So we don't see anything here. So how we can debug it? First of all, we can copy the items that we search for. Then we can open the teletrace. Everything is in the teletrace repository. So this is everything is open source. Here you can find in the guide a URL to teletrace. You can click on it. And then you can add a filter, for example, for different products. For example, if I look here for product, I can see that we have a span with different attributes and with attribute of product ID. If I click on it, I can search for the product IDs that I copied before. I will apply it. I will see that we have many errors here. I can infer it from the status. And I can see here the different spans that we have and that are compatible for our request. If we will click on one of them, it will open, because of the light, not see, well, okay. Oh, thank you. Thank you. So, so this is a trace. This is a graph view. Here you can see the time view. A time view is less interesting now because it's not a latency issue. But here we can easily understand that we have an error in our system. It's by clicking on the span, it's opening the relevant trace with the specific problem in our span, and it will show us the log. The log said that product catalog service failed, feature flag enabled. Okay, it's because I'm working with the demo, I can understand that the issue is in other service that running by OpenTelemetry that called product catalog failure. If I will open it, I will edit and disable this error. Click on save. And I will refresh everything. So I can see that everything is working correctly. So without any debugging, I can infer that I have an issue in our system, and I can find the root cause. And it's really cool solutions that can save you time. And if you save your time, it can save your money, because your teams will be able to troubleshoot and finding the root cause really fast. So I don't want to recommend any solution because you have really many use cases in the world, and you have many kind of solutions, part of them commercial, part of them open source. But I think it's really important in these days that every application that is running in a Kubernetes with different kind of pods and is in a microservices architecture, you want to have a good observability. Because if you have a good observability, you can find a root cause, and you can find the problems in your system really fast. So let's continue. So that's all. Do you have any questions? Yes. Mm-hmm. Mm-hmm. Okay. Mm-hmm. Okay, so really good question. So as I will repeat on the question, he asked if, for example, we're using the metrics generator. Okay, so what the overhead it produces on the in the performance perspective. For example, if we are creating many different metrics, in every second we provide many metrics, so how it influences on the application, on the application's performance. So for this issue, OpenTelemetry recommends to use sampling. That means that you will not provide every single request a metric. You will use a sampling that will produce a metric each time. For example, only 5% of your request will be sent to the metric server. So if you will have an error, you will easily can change the configuration for 100% to understand where is the issue. And after the troubleshoot, you can decrease this parameter, so it will be work with sampling. So this is the recommendation from OpenTelemetry on how to use and to overcome the performance issue. Yes?
Regarding the overhead,
Mm-hmm. Mm-hmm.
You recommend sending only samples, but there is any other way to, for example, aggregate this bunch of metrics happening during a period of time and set it in background?
Okay.
The cost of that
Mm-hmm. Mm-hmm. So you can use it in production, as I said. It will add some performance benchmark. So if you will compare your application without any instrumentation and with instrumentation, it will affect your performance. But the effect on your performance is really not big. But if you think about it, when we're talking about metrics, we want to understand that something is going wrong. We don't want to understand in every second that something wrong, that something don't work correctly. We want to understand the trend, that something happened, that if we're going back to the, for example, for this one, for here, we want to understand that the trend is changing. And I think that to infer that the trend is changing, we don't need to collect the 100% of the data. We can understand it only for collecting 5% or 10%. You can use and you can, for example, collect the whole 100% of your metrics. It's totally fine, but its effect on your performance. If you are using, for example, applications that is real-time application, you have to think twice if you use it or not. Maybe is other solution that will fit it more correctly. But if you are using a regular web application with many different pods, I think it's fine, and you can use it, and it will be okay. It's more helpful than harmful. And other questions? Mm-hmm. Okay, I will talk about it. It's a little different solution because it want to said that OpenTelemetry define a standard of telemetry data. If you are using X-ray or some, for example, some AWS solutions, they has the other solution. But in this day, we can see that more and more companies, for example, Datadog, New Relic, that are really big monsters in the observability world, they support OpenTelemetry natively. And why? Because you as a user, you want to make your company, your product to be fully observable, and you want to have the ability to have the choice which solution to use. Maybe I want for traces the Jaeger solution or Teletrace solution. And maybe for metrics, I want different solution. And I want to change between solutions. For example, today I want to use New Relic, and tomorrow I want to use different solution because it's more fit, it's more cheap for using. So as a user, I don't want to be coupled or to be combined to single solution. I want to have the ability to change between these different solutions because you have many different use cases and you want to be able to move between different kind of solutions. Another question? Okay, so if you want to start with OpenTelemetry, you can reach me by Twitter or by LinkedIn. And if you want to, you are more than welcome to try to use Teletrace and OpenTelemetry. They really can help you to understand how to work and how to start and how to make your application to be observable. You're more than welcome to play with the demo. It's like a playground, a sandbox to view how everything works. You can, for example, disable the OpenTelemetry and enable OpenTelemetry, and you will see the different benchmark aspects on how it affects on your system. So it's really cool tool, and I think it's really important. Yes. Yes.
Say, for example, you have a complex like Kubernetes cluster,
Mm-hmm.
and you have mini microservices and mini containers.
Mm-hmm.
You need like OpenTelemetry in every single container,
Oh.
or you need just like in the top level?
So this is a good example. Let's say, for example, as he mentioned, you have, for example, a Kubernetes cluster with many different applications. So how I start? For this purpose, you can use the auto-instrumentation. Auto-instrumentation will run beside your application in some agent. Maybe you will need to add some minimal change to every of your application, but not in all languages it's needed, not in all programming languages it's needed. Then you will run a collector in your as a different pod in your application. You can configure, you can create one configuration that all the applications in your system will send the data to this collector, and this collector will export this data to some telemetry backends that you can choose. So you don't have edit to your deploy. It can be in automatic instrumentation, but basically, yes, it has to be in and to gain the data for every of your application. But you can start from only a simple case. You don't have to gain observability for all your application from the first day. You can start easily with and do it step by step. So, any other questions? Yes.
Only for example, you don't want to use for logs.
Okay.
Using Rhino, for example,
Mm-hmm. So logs, it's only one pillar of the observability. It's answer as why something happened, right? You have a data record that tells us, okay, you have an error. We all of us created some hello world project and it created a log. But think about it, what happened if you have an error that occurred in one microservice, how you correlate between the different data, how you find where is the error happened. For example, if you have an error in some microservice, in one microservice, how you understand which request is responsible for this error. It's really hard, and to troubleshoot and find the root cause can be very challenging. Think about it. You have like a huge application with many microservices. Each microservice can have can be scalable. So you can have like some you can have many kinds of pods of the same application of the same microservice. So to find which of them is responsible for this log can be very challenging. So in this day, I think it's very important to be always observable, to know, to answer always keep in your head that you want to answer 3 questions. Why something happening, what happened, and where it happens. If you will answer this question, I think it will help you to debug your system and troubleshoot your system. Another questions? Okay, so thank you very much, and welcome.